Okay, this is the missing audio from the lecture capture system, which didn't record properly. So what I'll do here is I will record the lecture. I'll not show you the slides, but I'll record the lectures and mention the slide number, and you will be able to associate the audio of the slides with the actual slides. So slide number 1 is tree and graph traversals. We will study tree traversals, breadth first search, depth first search, and topological sort in this slide, in this lecture. I will break it up into smaller parts just to make sure that everything is recording correctly. And so you may have at the end 2 or 3 different small lectures that you can associate with the lecture slides. So slide number 1, tree traversal. Now we will talk about tree traversal in this lecture, and what is the purpose of tree traversal? Purpose could be search for a particular item. After all, we store some items in a tree. We may test equality of 2 trees. We may copy a tree, create a tree, or display a tree. There are 2 main techniques in tree traversal. One is depth first search or depth first traversal. The other is breadth first or level order traversal. So that was slide number 2. Slide number 3 is depth first traversal. Now depth first traversal has 3 different techniques associated with it. The first one is the preorder traversal, and preorder traversal, you can see the code at the top of slide number 3. First thing to do is to check whether the tree is empty or not. If the tree is empty, of course, there is no meaning of traversal. So if the tree is non-empty, then we visit the root of the tree first, and then we performed a preorder traversal of the left subtree, and then we performed a preorder traversal of the right subtree. So what do you mean by visit the tree, visit the root of the tree? Basically, we'll illustrate that by printing out whatever is stored at the particular nodes. So you can see that in this particular tree, some nodes have stored some arithmetic operators like plus, minus, multiplication, etc. And some other nodes have numbers. So in this case, we have to first visit the root of the tree, and that stores the number plus. So we print that. You can see at the bottom, we are printing the contents of the tree. So plus is printed first, and then we recursively visit the left subtree. And the root of the left subtree has the multiplication symbol. We print that at the bottom, and we go left further. And the left of that subtree has a plus symbol. We write the plus symbol here. And then we go down, and this node has stored 1 and this node has stored 2. Now you can see that once we reach the node 1, reach the node that is storing 1, we don't have anywhere to go below that. So we come back from here, we come back to this node, and then go down to this node, and we print the symbol or the number 2, and then we have nowhere to go any further, so we come back to this node and explore the right subtree of this node. And what does the right subtree store? The number 3. So we write the number 3 here, and then we have nowhere to go, so we come back and we go up here. But we have already processed the node plus, so we go down to the right subtree of that node, which stores minus. So we print minus here, and then we go down left of that, which is the node storing the multiplication symbol. So we write the multiplication symbol, and then we come to the node 4 and print that. We have nowhere to go now, so we come back here and go to the right subtree of this node, which is the number 5. And then we have nowhere to go below that, so we go back, and this node has the right subtree, which is 6. So we write 6 here. So this is basically preorder traversal. Here you can see the recursive nature. We first visit the root, visit the left subtree recursively, and visit the right subtree recursively. I'll just stop here, and I will check whether everything is recording correctly, and then I'll continue.